Okay, we're going to end up our session then with Alannah Biega, who has worked through the Renew Zoo program at Simon Fraser University with Arne Moores, and she's going to talk to us about amphibians and zoo conservation programs. Alannah works for Oceanwise, which is this blanket organization that includes the Vancouver Aquarium, and she's involved with the shoreline cleanup project. So she completed an internship at the Vancouver Aquarium, and they kept her on. So that's good news for us, for the program. And we're hoping she will replace any veterinarians that are involved in conservation programs soon, right? All right. Alannah, thank you.
Thanks. Thank you, Albrecht. I'm really happy to be here today and talk to you from the perspective of a student and a young professional entering the zoo and aquarium field. So to give you a little bit more background on myself, I was one of the first students to enter the Renew Zoo program, and I was also the first graduate of the program. So here's a picture of myself and other students and collaborators at the CASA meeting this year, so that's Canada's Accredited Zoos and Aquariums. And during my time in the program, I served as the student representative on the program committee. I took the Renew Zoo course, and I completed an internship at the Vancouver Aquarium. Now I'm going to spend a little bit of time telling you about my experiences in the program, but before I do, I'm going to backtrack a little bit, because my interest in zoos and aquariums started before that. This is a picture of me at the Toronto Zoo. I worked there during my undergraduate, and I was taking zoology at the University of Guelph. And I was leading educational programs for the public. And that's when I first became really interested in the role that zoos play in conservation. And I started a master's program at Simon Fraser University investigating just that. When Renew Zoo launched, I was a year into my studies, and I traveled to Yukon for the CASA meeting to present on my research so far and what type of research a student could do within the Renew Zoo program. And at the time, I was really tackling one question in particular, and that was, what is the conservation value of animals in zoos? Are they the right species, the ones with the greatest conservation need? Now, of course, there's many ways that you can go about attempting to answer this question, but my research and this talk will focus on two in particular. First, I'm going to talk about the representation of threatened species held in zoos. And then second, the effectiveness of captive breeding programs. So you can think of these two topics as first, which animals are in zoos, and then second, how are they doing once they're in zoos? And are they actually contributing to recovery targets? And I chose to look at one taxa in particular to answer this question, amphibians. That's frogs, salamanders, and caecilians. Amphibians are one of the most imperiled class of vertebrates. They face massive declines globally. So if you look at this graph and look at the red bars, you can see that approximately 1/3 of amphibian species are at risk of extinction. And that's higher than levels for any other class of vertebrates. The causes of this decline are complex, ranging from habitat loss, invasive species, and infectious disease. So frog populations globally have been plagued by chytridiomycosis, which is an infectious fungal disease that's proved very hard to treat in the wild. So the only hope for some of these species and populations is the establishment of captive assurance colonies. Now, the CBD, which is the Convention on Biological Diversity, and the IUCN, the International Union for the Conservation of Nature, recognize the need for ex situ conservation. So when I say ex situ conservation, I'm talking about management strategies under which individuals are maintained in a controlled or a modified environment. So this could include captive breeding, reintroduction, or head starting. And ex situ management has been absent from a lot of traditional conservation organizations. So a lot of these activities have been spearheaded by zoos. At the same time, zoos have been switching their role to do more ex situ conservation, partly in response to public pressure, with the rationale that animals kept and bred in zoos are ambassadors for their species, and through captive breeding and reintroduction, can serve as an insurance measure against extinction in the wild. An example of a zoo-supported program is Amphibian Arc. So Amphibian Arc is an ex situ focused conservation organization that helps advise and coordinate global captive conservation efforts for amphibians. So they helped coordinate and manage a lot of programs in specialized breeding centers, often located in high biodiversity areas in the tropics. So I have some examples of that here. This trailer is a specialized breeding center in Panama, and they even have a breeding center in this nunnery in Mexico. So although a lot of these are in high biodiversity areas of the tropics, as I mentioned, they also support programs in North American zoos. So to give you a Canadian example, this is the Oregon spotted frog. It is one of the most endangered amphibians in Canada. It lives in BC's Fraser Valley, and it's currently being bred by the Vancouver Aquarium and the Vancouver Zoo. And the number of amphibian species in zoos and captive breeding programs, such as this one, is increasing. Zoo holdings have nearly doubled since 1994, and the number of species in programs such as that one has increased by 57% since 2007. But are these species the right ones? Are they the ones with the greatest conservation need? And that brings us to the first topic. Now, fortunately, zoos keep track of what they keep. ZIMS, which is the Zoological Information Management System, keeps a record of global zoo holdings. And using that, as well as records from Amphibian Arc, I was able to tally 532 amphibian species in 516 institutions. So this includes large commercial centers, such as the Vancouver Aquarium, Toronto Zoo, but it also includes those specialized smaller breeding centers in the tropics. Once I had a list of all species in zoos, I then matched them up to their closest relatives not in the zoo. So here we've got two rain frogs. The one on the right is in a zoo, and on the one on the left is its closest relative, its sister species, that's not in the zoo. So if zoos are targeting threatened species, we would expect the one on the right, that's in a zoo, to be more threatened than its close relative in the wild. To assess this, I looked at traits related to conservation need. So I used IUCN Red List status as a measure of current global threat. I looked at range size. The species that have smaller geographical ranges are at greater extinction risk. And also I used habitat breadth as a measure of specialization, where species that are confined to one or few habitats are at greater risk than species that can live in several. And I found that amphibians in zoos are equally as threatened as their close relatives in the wild if we look at their IUCN threat status. However, they had a 3.5 times larger geographical range and a 27% broader habitat breadth than their close relatives in the wild. Now, this isn't good because this means that species in zoos are biased towards large-ranging habitat generalists. If we go back to our example with the rain frogs, we can see that the rain frog in a zoo is just as endangered as its close relative in the wild if we look at current threat status, but it has a much larger geographical range size, and it can live in tropical montane and lowland forest, whereas its close relative in the wild can only live in tropical montane forest. So the one in a zoo is at lower extinction risk in the future than its close relative. Now, of course, zoos house species for many reasons aside from threat. Could be for educational value, or zoos also breed species to gain husbandry techniques for holding threatened species in the future. So just because a frog is in a zoo does not mean that it's part of a conservation breeding program. So I redid the analysis, and this time I only looked at species that are in conservation breeding programs, like the one for the Oregon spotted frog you saw earlier, and scored them for the same traits relating to extinction risk. And when we found that we looked at species that are in conservation breeding programs, amphibians involved in these programs were more threatened than their close relatives in the wild. And importantly, they weren't the large-ranging habitat generalists that we saw in zoos. So I've given you another example here. We've got the mountain yellow-legged frog, which is in a conservation breeding program, and its close relative, its sister species, the Cascades frog. And you can see that the one in a conservation breeding program is more endangered, more threatened. Now in this example, the one not in a zoo has a larger range, but on average equal range sizes, and it could inhabit roughly the same number of habitats. So to recap this section, if we expect zoos and conservation breeding programs to be holding and targeting threatened species, then we expect these species to have increased IUCN threat levels, smaller geographical range sizes, and narrower habitat breadths. Now, if we look at zoos, we're finding that they have equal threat status, but they have larger geographical ranges and broader habitat breadths. Now, fortunately, conservation breeding programs are increasing the representation of threatened species in ex situ collections. So now we're going to move on to our second topic. So that's how are these species doing in zoos, and what's the effectiveness of these captive breeding programs? So here I'm showing data from Amphibian ARC, and you can see that only about half of the programs, captive breeding programs, are reproducing offspring in captivity, and only about 1/5 of these programs are reproducing to the second generation. So even though amphibians are considered generally suitable for captivity, there's clearly some barriers to achieving breeding success for a lot of these programs. So I was interested in what are the characteristics of a successful program? Now, if we knew that information, then it could be applied to prioritizing species for future programs, so that we're not wasting money bringing species in that aren't going to breed in captivity. Now, maybe this difference in success is determined by intrinsic factors. So not all amphibians are going to be equally suitable for captivity, and some might have life histories that present husbandry challenges. Or maybe this difference is best explained by extrinsic factors. So that could be funding or expertise of staff at a particular institution, or even the location of the institution itself. So whether it's in the species' native range or outside of it. So to answer this, I collected data on 285 captive breeding programs globally. So the location of these programs can be seen on this map, with the size of the dot representing the number of programs at a particular institution. I got this data again from ZIMS, that's Zoological Information Management System, as well as Amphibian ARC and literature. And it's ranged over a total of 210 species in 91 genera and 38 families. You can see them, all the families on this phylogenetic tree here, with the color of the tip representing the proportion of successful breeding programs for species in that family. So tips in blue represent families with a high proportion of captive breeding success, and tips in red represent families with a low proportion of species in successful breeding programs. Programs were considered successful if they produced viable offspring, defined as animals which were both bred and raised to adulthood in captivity. So you can see that there's a lot of variation in breeding success among these families, but of course there are different sample sizes for each family. So I'm going to zoom in to families for which I had at least 10 species in my data set. So here I'm showing the mean proportion of success, and you can see that it's still ranging from 35% for lungless salamanders up to 72% for shrub frogs. So seeing that we still have this variation among families in breeding success, I wondered if this could be attributed to aspects of their biology. And this is where the zoo and aquarium community really came in. So I've never bred frogs, I don't know a lot about husbandry, and so I really relied on the expertise of experienced zookeepers for this. So I just wanted to take this moment to thank all the people that took the time to meet with me or Skype, as well as those who contributed data or funding for this project. And together we came up with this list of intrinsic factors that might be related to breeding success. So this includes aspects of the species biology and the reproductive biology. And I'm not going to go into why I chose each of these factors, but I'm happy to answer questions about that later. Breeding success could also be related to extrinsic factors. So that's the institution itself, which could be the equipment there or expertise of staff, the location, so whether it was located inside or outside of the species' native range. I used number of relatives held ex situ as a proxy for the amount of husbandry knowledge that might be available for breeding species within that genus. And I used GDP of host country as a proxy for funding. So I didn't have data on funding of the programs directly, so that was the closest I could get. And I ran each of these intrinsic and extrinsic variables, tested them each independently, including or incorporating the effect of phylogeny, so that's the relationship among species, and also institution. So by including institution as a random factor, it helps account for some of those variables I couldn't measure directly, such as expertise of staff. So now I'm going to show you some results. So interestingly, low GDP countries did just as well as high GDP countries. So here I've mapped the distribution of the GDP for successful and unsuccessful programs. And you can see that the distributions are overlapping, so there's not much difference there. But if we look at two of these low GDP successful programs, we find two well-funded programs. So even though these are located in low GDP countries, they're funded by North American zoos. So this goes to show that GDP of host country is not the best proxy for funding, and you'd have to collect data on funding directly in order to test this relationship. So I did find an effect of some of the biological traits I looked at. So here we have developmental habitat, and here I'm showing the distribution of the posterior coefficients for mean probability of breeding success. So in pink, we've got species that develop in aquatic habitats, and in blue, we have species that develop in terrestrial habitats. So that red dashed line here represents the null hypothesis, so that's no effect on breeding success. And those white dashed lines represent the median probability of breeding for aquatic species and terrestrial species. And you can see that for aquatic species, it's 47% lower than terrestrial species. Now, this could be because aquatic species are harder to keep in captivity. You need to be able to know their water chemistry parameters that they need, and not only be able to recreate those, but maintain them. And a lot of times, these water chemistry parameters are not even known. As well, I found species with parental care had higher breeding success than species that lack this trait. So that was 22% higher for species with parental care. This could be because species with parental care have higher survival rates in general. It could also be because aquatic species tend to exhibit less parental care. So this finding could be related to the last finding as well. So out of all the traits I looked at, here are the ones that had some effect on breeding success. But a lot of these effects weren't consistent. So out of all of these traits, only developmental habitat and parental care had a consistent effect on breeding success in over 90% of my statistical iterations. So while it would be really nice to have a species and then be able to predict how well it'll do in captivity based on its biology, it's not a matter of looking at these traits independently. Instead, breeding success likely comes down to knowing species-specific knowledge on natural history, breeding triggers, and wild habitat parameters. And this really reinforces the importance of engaging with field biologists and making sure that this data is published and it's accessible to the zoological community. So just to recap, we were trying to answer, well, what is the conservation value of animals in zoos? So first, I looked at the representation of threatened species held ex situ or in captivity and found that zoo collections do not reflect the species of highest conservation concern. However, fortunately, conservation-focused breeding programs are helping to increase representation of threatened species in collections. Then I looked at the effectiveness of captive breeding programs and found that not all species will breed in captivity, and differences in success did vary by habitat and by parental care. And also collecting and publishing species-specific data on microhabitat and life history will hopefully increase husbandry expertise and captive breeding success. So that concludes the research portion of my talk. And now I'm going to jump back a little bit to my experiences in Renew Zoo. So for my Renew Zoo internship, I did an internship at the Vancouver Aquarium under the Great Canadian Shoreline Cleanup. So this is a direct action conservation initiative of Oceanwise, which is the nonprofit organization of which Vancouver Aquarium is a part of, and WWF Canada. So we help and support individuals that lead shoreline cleanups around the country. So every year, we support around 2,000 cleanups with over 60,000 participants. And this program has been running for 25 years. This is a long running program. It's also a citizen science program. So when people go out and they lead a cleanup, they track what they're finding on shorelines. So we have a very extensive, very cool data set of shoreline litter. And this helps raise awareness of water pollution, as well as helps us determine the sources of shoreline litter. And this is where I saw my opportunity. So I was able to take my background in data analysis and relate it to this citizen science program. I had a very positive experience during my internship. During the first month, I led a cleanup outside of Richmond, BC, that had over 300 people attend. Shortly after I began my internship, our communications advisor went on maternity leave, and I took over all the social media duties. So that was a really great experience for me because I was able to learn how to take on an organization's voice and develop content in a way that's going to be digestible in a single Facebook post or a 200-character tweet. Now, it can be hard to juggle an internship while finishing your master's and doing a course, but my supervisors were really great and accommodating and allowed me to do both. After 2 months of my internship, I was offered a full-time temporary contract with them under a wage subsidy program offered by the United Nations Association of Canada. So this is an opportunity I wouldn't have known of otherwise. It wasn't advertised, and I was only offered it because they already knew me through this Renew Zoo internship. So since being hired, I've been involved in outreach, planning more events, and I've helped develop the citizen science aspect of the program. So recently I've used new tools to map and visualize the data that we're getting from shoreline cleanups. So here I developed this map that allows users to go in and zoom in on their geographic area and see what the sources of shoreline litter are near them. So this got a lot of attention on Twitter, it was shared on social media. It was also covered by CBC in 2 different articles. So this was really cool to be able to use the skills I learned during my master's and apply them to the citizen science program. So to summarize, Renew Zoo helped me not only within my research and making connections for that, but also get professional experience. So I made a lot of connections at Oceanwise or the Vancouver Aquarium. I made friends in communications, marketing, design, content, education, and really realized how many diverse fields there are even within a zoo. It also helped me establish connections outside of the aquarium. So with WWF Canada, as well as other nonprofits working in a similar field, and with municipalities as well. So even though I'm on a short-term contract and I don't know what is next for me, I feel a lot more confident having this professional experience behind me. So with that, I'll thank you for listening, and I'm happy to answer any questions you have.
How great is Renew Zoo?
Pretty great.
Have you been able to do any work with any of the spotted, like the Oregon spotted frog? Is there any? Who's doing that work?
That's Darren Smythe is doing that work.
Okay, is that in collaboration with the province or?
It is. So there's a recovery team that has
Okay.
members on it from the province,
Right.
as well as the zoo and as well as SFU. So the Wendy Palin lab has been really involved in the recovery efforts. And I've sat in on those meetings, but haven't done too much more than that. Yeah.
I was just wondering about public or popular attention towards amphibians and the struggles of fundraising because the public's interested in giraffes and elephants and not as interested in amphibians and how do zoos and navigate that kind of general dilemma.
Yeah, I think frogs are never going to be as charismatic or drawing as big of crowds than like an elephant or a tiger would. But I think for many zoos, it's making that connection to your local environment. So the whole like think global, act local thing. So making that tiger, and especially young kids love going out and catching frogs or going out to their local pond or their backyard and trying to make that connection for them, I think is the best way to do it, but it's hard to compete.
Is the citizen science movement helpful?
I think so. There is a frog watch program out of the Toronto Zoo, as well as like turtle tally, and so it's getting citizens engaged, and then I think that helps as well.
and it also makes things worse. The problem is most of those people don't think about spread of disease. You talked about Kitrid, I work on rhinovirus. To be honest, one of the worst things they do is bioblitz, like literally packing 10 students in a chopper, fly them to 10 wetlands in a day. One wetland is infected, after they have 10 wetlands infected, and no one talks about it. And like I see, it is important to have stuff like that, but there's still a lot of stuff to do, in my opinion. Like, and while parks gets better, the government is still really bad with that, in my opinion. I don't know. It's like, for sure, people have to learn stuff. To be honest, in Canada, one thing always works is mosquitoes. Just think about how many mosquitoes we would have if we don't have frogs. That's one thing I really like. Well, I'm way further north than here, but that's one thing to get people quite fast. And like, if you really talk with people, most people recognize that they have less amphibians, but they just don't think about it. So, and that's another thing which is, I think, important, but yeah.
Yeah.
Can I ask a quick question? Do they have Oregon spotted frogs on display at the Vancouver Aquarium?
Yes, they do.
They do.
Yeah, they have signage about the
Yeah.
aquarium.
Any other questions? Thanks. Oh, sorry.
I
go
have
ahead.
one last question. It's more biological though. So you chose your sister taxa,
Yes.
but there's obviously multiple sister taxa related species. So how did you narrow down the one that you used as a comparison, or do you take a species mean?
So what we did is we only looked at monophyletic pairs, so it could be up to 5 species that were sister taxa,
Mhm.
and then we took a modal average or an average for the continuous variable, so we looked at that, but only for monophyletic pairings. So
And was there any phylogenetic inertia related to the analysis as well?
no, because of our statistical setup.
Right. So the pair design.
It controlled for all of them.
Sorry.
Don't be sorry. Thank you, Alannah. And thanks everyone for coming. Our